The sun has just delivered a blow that is forcing scientists to rethink everything they thought they understood about space weather. What we are witnessing right now is not just another solar flare. Astronomers are already calling it the storm of a generation, an event so powerful that it has shattered records that stood unbroken for more than 20 years. For nearly 2 decades, the sun appeared relatively restrained. Solar cycles came and went, but truly extreme events were absent. Many experts quietly assumed that the most violent outbursts belonged to the past, to history books and archived datasets. That assumption has now been destroyed. This eruption did not merely approach previous records, it surpassed them. To understand the scale, we need to look back. In October and November of 2003, the sun unleashed a series of massive eruptions known as the Halloween storms. At their peak, instruments recorded an X17.2 class solar flare, so powerful that it overwhelmed some sensors. For years, this event stood as the benchmark for extreme solar activity in the modern era. What has just occurred exceeds that benchmark. Scientists monitoring real-time data confirmed it with disbelief. The numbers climbed beyond expectations, beyond models, beyond what many believed was realistically possible in the current solar cycle. A new record has been reached, the strongest solar flare of the 21st century. But the flare itself is only the opening act. The true danger lies in what followed. A massive radiation storm, also known as a proton storm. This is a flood of high-energy particles accelerated to near-relativistic speeds and hurled directly into interplanetary space. When these particles reach Earth, they interact with satellites, astronauts, aircraft, and the planet's magnetic shield. On the official 5-level radiation scale, the S scale, this event has been classified as S4, severe. To grasp how rare that is, consider this. The last S for radiation storm was recorded in 2005, almost 20 years ago. The highest category, S5 extreme, has never once been officially recorded in the history of the space age. Humanity is now operating one step below the absolute theoretical maximum. This alone makes the event historic. The closest parallel once again comes from 2003. During the Halloween storms, the radiation level reached S3, classified as strong. Even then, the consequences were serious. A major NASA scientific satellite was permanently disabled. High-frequency radio communications failed across large regions. Aircraft were forced to reroute. Maritime navigation systems experienced outages. Auroras were seen far beyond their usual latitudes, reaching as far south as the Mediterranean. What we are dealing with today is significantly more powerful. Within minutes of the eruption, alerts were issued across the global space weather monitoring network. Satellite operators began emergency procedures, placing spacecraft into safe mode. Non-essential systems were shut down. Sensitive electronics were powered off. Every precaution was taken to prevent irreversible damage. Satellites are particularly vulnerable to radiation storms. High-energy protons can penetrate shielding, flip bits in memory systems, permanently degrade solar panels, and cause sudden system failures. In extreme cases, satellites can be lost entirely, silent, dead objects drifting in orbit. Modern civilization depends on these machines more than most people realize. Satellites handle GPS navigation, financial time synchronization, weather forecasting, internet backbones, television broadcasting, military surveillance, and disaster response. A failure in space does not stay in space, it cascades downward. Astronauts face an even more direct threat. On board the International Space Station, radiation levels are closely monitored. During severe storms, crews are instructed to move into the most shielded areas of the station, where water tanks and equipment provide additional protection. Outside Earth's magnetic field, such as on the Moon or during deep space missions, this level of radiation would be potentially lethal. This storm is a stark warning for humanity's future beyond Earth. Plans for lunar bases, long-term space stations, and missions to Mars all assume periods of relative solar calm. Events like this expose just how fragile those assumptions may be. Meanwhile, Earth itself is not immune. As the charged particles reach our planet, they collide with the magnetosphere, compressing it, distorting it, and injecting enormous amounts of energy into the system. This triggers a geomagnetic storm, forecast to reach E4, severe, the second highest category on the geomagnetic scale. For comparison, the infamous March 1989 geomagnetic storm, the one that caused a 9-hour blackout across Quebec, Canada, was also a G4 event. That storm damaged transformers, disrupted radio communications, and forced emergency responses across North America. Geomagnetic storms induce powerful electric currents in long conductive structures. Power lines, pipelines, railway systems, undersea cables all can act as antennas for geomagnetically induced currents. Transformers can overheat. Protective systems can trip. Voltage instability can spread across entire regions. Power grid operators in high-latitude regions are on high alert. Scandinavia, Canada, northern Russia, and the northern United States are particularly vulnerable. Controlled outages may be implemented to prevent catastrophic damage. The goal is not convenience, it is survival of the infrastructure itself. A destroyed transformer is not easily replaced. Some take months, even years, to manufacture. A widespread failure would not be a temporary inconvenience, it would be a long-term crisis. Communication systems are also at risk. High-frequency radio waves, used by aviation, shipping, and emergency services, can be completely disrupted during severe space weather. GPS and GLONASS signals may become inaccurate or unavailable. Aircraft flying polar routes may be forced to divert, increasing fuel costs and flight times. Maritime navigation may revert to older, less precise methods. And then there is the sky. As the storm intensifies, Earth's upper atmosphere begins to glow. Charged particles collide with oxygen and nitrogen atoms, causing them to emit light. Curtains of green, red, and violet ripple across the heavens. These auroras are not merely beautiful. They are visible proof of a planetary-scale energy transfer. During events of this magnitude, auroras can appear far from the poles. Cities that have never seen them before may suddenly find the night sky alive with color. Moscow, St. Petersburg, Central Europe, the northern United States, possibly even farther south. For many, it will be the most spectacular natural display of their lives. For scientists, it is a goldmine of data. Instruments across the world are recording every second. Particle flux, magnetic field distortions, ionospheric density changes. This information may redefine models of solar behavior and help answer a crucial question, now dominating the discussion. Is this the peak or only the beginning? History offers a sobering clue. Extreme solar events often arrive in clusters. The 2003 Halloween storms were not a single eruption, but a sequence of powerful flares and coronal mass ejections over several days. If this pattern repeats, Earth may face additional impacts in the near future. And beyond recorded history lies an even darker reminder. In 1859, the Carrington event struck Earth with such intensity that telegraph systems caught fire. Operators were shocked, and auroras were seen near the equator. If a storm of that magnitude occurred today, the consequences would be unlike anything humanity has ever experienced. This is not an apocalypse, but it is a stress test for our technology, our infrastructure, and our assumptions. Over the past 20 years, civilization has become exponentially more dependent on space-based systems, all while the sun remained deceptively quiet. That quiet is over. We live inside the atmosphere of a star capable of releasing, in minutes, more energy than humanity has produced in its entire existence. Today, it has reminded us of that reality. We are watching, we are measuring, we are hoping, and we now know, without any doubt, that this will not be the last time the sun reminds us who is truly in control.